Hello, this is Transistors, Part 3, Transistor Amplifiers, calculating the AC component. First step, we start with the biasing. It's a DC biasing. We'll use a voltage divider biasing to set up the DC components of our circuit. So exercise 1A, calculate the following. What's the base voltage? VB. So VB, what we do is we have a voltage divider with R1 and R2, and we just calculate what the voltage is across R2, and that's our base voltage. What is our voltage VE? You take the base voltage, subtract the base emitter voltage, VBE here, which is 0.7, and you'll get VE. Once we know VE, well, we know our emitter resistor. We have our emitter voltage, Ohm's law. Voltage over resistance gives our current. That'll be our emitter current. Emitter current's equal to our collector current. Once we know our collector current, then we can figure out the voltage drop across RC. Once we know the voltage drop across RC, our supply voltage, VS, minus RC will give us our collector voltage. Lastly, what is our collector emitter voltage, VCE? Take our collector voltage, subtract our emitter voltage, and it would be our VCE. The AC component is treated separately from the DC component, two separate animals. AC is actually pretty simple. What we do is we add a capacitor. It's a decoupling cap. So basically what happens, we can put an AC signal in, and what will happen to the VN will go into the base. And there's a DC voltage here, and what will happen is that AC signal will ride on the DC voltage going in here. Vout is taken from the collector. We have a decoupling cap here also, so we have a DC voltage here. This cap will allow the AC to pass through, and we'll get our AC signal out. The answers to the previous exercise are available in the video description and on Brightspace. So if this is an amplifier, what's the gain? Well, the gain is determined by RC and RE. So the gain is determined by this resistor over this resistor. And it's negative, so it's an inverting amplifier. So the gain, AV, is equal to minus RC over RE. In our case, we have a 5.6K resistor, and we have a 4.3, so the gain is minus 5.6K divided by 4.3K gives us minus 1.3. The negative sign indicates it's an inverting amplifier, and we have here's our sine wave, and our output is out of phase. Vout is equal to gain times Vn. Vn is 100 millivolts. We said our gain is minus 1.3, so minus 1.3 times 100 millivolts peak to peak gives us a Vout of 130 millivolts peak to peak, 180 degrees out of phase. Exercise 2A. First part we always do is figure out the DC components. What's the base voltage? What's the emitter voltage? What's the emitter current? What's the collector current? What's the voltage drop across RC? And what's the collector current? And what's VCE? Then what we do is we figure out what is the gain. Gain's pretty straightforward. It's minus RC over RE. That's our gain. What is Vout? Vout is equal to Vn times our gain. The answers are available in the video description and Brightspace. Now, we can make a transistor voltage follower out of this circuit, and the output this time is taken off of the emitter. So we use a decoupling cap off the emitter, and we have Vout. Our gain is 1. It's actually a little bit less than 1. It's like 0.99, but for all intensive purposes, it's just 1. Vout is in phase with Vn, so we have a sine wave coming in, we got a sine wave coming out. They're in phase. Vout is equal to Vn because we have a gain of 1, and we don't need RC. So we don't need the RC resistor. What happens is that we'll have a current IE that's calculated by this resistor, and what happens is that we don't need a current limiting resistor here because this one's going to limit the current. VC is going to be equal to Vs. So we'll have a transistor voltage follower exercise number 3. Calculate the DC components the same as we did previously. Calculate the base voltage. We have our voltage divider here. Emitter is 0.7 volts less. Emitter current is our emitter voltage divided by our emitter resistor. We don't really need to calculate our collector current. It's the same as the emitter. There's no collector resistor, don't have to calculate it. VC is going to be the same as VS, 20 volts here. AV is 1, it's a voltage follower. Phase is going to be the same. Whatever we have on the input goes on the output. So let's do a quick review here for transistor inverting amplifiers. We calculate the DC components first. Vn comes in on the base. We have a decoupling cap, so that way we can isolate our DC signal here from our input signal. Vout goes out via the collector, so we have our collector, we have a DC voltage here, we have another decoupling cap, so that way we can strip the AC out, let the AC out, keep the DC on this side. The gain is the collector resistor over the emitter resistor, and it's negative, which means the output is out of phase. Review the transistor voltage follower. We calculate the DC components again, calculate the base voltage, emitter current. VC is equal to Vs. Vout goes this time out the emitter. Vout is in phase and the gain is 1. So 375 millivolts peak to peak on the input. We get 375 millivolts peak to peak on the output. That completes this presentation on transistor amplifiers. And that's it for today.